Hello, hello, hello. I hope you're all well. Crumbs, bit of a rush tonight, but I'm here. I was on the A23 not very long ago, so I hope you're all good. Please introduce yourself in the comments, say hello. It's lovely to see you all again, or to be here. Can't actually see you, but it's great to be here. Hope you had a good day. I hope you didn't get too wet going home. So our plan today is to do network threats, or more precisely, resolving network threats. That's the grand plan today. So please say hello in the comments, and we shall get this show on the road. There is quite a lot to cover today, so I'm going to first of all go for a few basics, and then I'm going to try and give you the overview so you understand how you can answer these sorts of questions. Hi Aditya, hope you're doing well. Hope all is well. Aditya managed to find an extra mark in his mock exam today, which is very cunning, mainly because I can't add up to 60. Hi Jumbo Lizard, how are you? Good to see you. Thanks for coming. Hello Hash Brown, how's things? Hope all is well. Yeah, so here we are again. So we're at the second part here. So last week we looked at network threats and what they were. And so you're going to need to be able to define them and how these threats manifest themselves. We talked about DDoS, one of the more complicated ones, and we're going to look now at how you can prevent all of these network threats. Usual scenario is that they will give you a context, a scenario even, and they will give you that scenario and they will ask you to suggest what network threats present themselves and or how you can prevent them. So that's the grand plan, okay? So first of all, we've got anti-malware software. If you learn nothing else, now don't forget, mal in French means bad, so it's literally anti-badware. So it's to stop bad things happening to your computer. So what does anti-malware do? Now don't say antivirus, because antivirus is a type of anti-malware, but there are many different kinds. So anti-malware is that umbrella under which all of these sit. So we've got anti-malware software, which blocks malware from entering the system, and it scans the system for potential threats. And you've got antivirus software, anti-spyware software, and that will defend against other attacks as well. So don't forget, the spyware, that tends to be more annoying. The spyware is to try to find out information. Perhaps it'll look at a keystroke logger, and a keystroke logger looks to see which keys you're pressing. So for example, if there was spyware that was installed on in a bank's computer, they could figure out what passwords they were entering to gain access to accounts. And same thing at home. People tend, even though they shouldn't, to use the same passwords over and over again. So one password might give you access to all sorts of different platforms. Banking, of course, slightly more tricky. That tends to be two-factor authentication. And don't forget, two-factor means that there's usually some information like a password and a thing like a phone, and you've got to have both. So that is anti-malware software, and I'm going to go into a bit more detail on that in the end. I'm aware I've got a lot to get through here today. Is there bienware? That's a very good question. So bien is French for well. Is there wellware? And I suppose the answer is yes. And that falls into system tools. So although it's not called bienware, although we should actually market that, Aditya, because there could be a lot of money there. Think about disk defragmentation. That's a sort of bienware because it makes your system better off. Bienware. A nice idea. There could be something in that. It's your idea though, so you better copyright it tonight before I get to the patents office. So we've got penetration testing. Now, penetration testing, penetration is to get through the defenses. That's the idea of penetration. And penetration testing is particularly effective against DDoS attacks, but other attacks too. So penetration testing, it will check to see whether a network is secure, and it's a test that's performed under a controlled environment. So it's mounting a sort of hoax attack against your own servers. Let's have a look. Hello, Flynn. How are you? Great to see you. And hello, Matthew. How are you? Hope all is well. Right, so penetration testing. Tests are performed under a controlled environment to try to simulate the attack to see where the vulnerabilities lie. So that's penetration testing. And something else that can be what's the word I'm looking for, can be simulated in a penetration test is large volumes of traffic. And don't forget, it's large volumes of traffic, all those zombie computers. What am I talking about when I'm saying zombie computers? That's the DDoS attack, isn't it? We've got the master bot run by the hacker who's infected loads of nodes, loads of computers. They've all got a bit of malware there. And when the hacker decides to press the button to launch the attack, lots and lots of traffic gets sent towards the server with the intention of knocking it over and making it more vulnerable. So penetration testing can simulate that, huge volumes of traffic, to see how a server or a node behaves when it's under pressure. All right, so that's penetration testing. Firewalls. Firewalls prevent unauthorized access to or from another network. So typically a firewall, by the way, can be hardware or software. It can be either or both. And it examines the data packets coming into or leaving the network to make sure that they don't contain any malware of any kind or any malicious code, which is designed to corrupt and delete files or to steal data. All right, and it blocks access to unacceptable packets. What a firewall typically does, a bit like antivirus software actually, is that it will, when it comes across a packet that it is concerned about, which could be dangerous, it'll put it in a quarantine area, in a sandbox area. We think about Minecraft as a sandbox game where you can do whatever you like, but a sandbox in terms of a computer system is a place where you can do things in relative safety. So it'll put that suspicious file in the sandbox, in the quarantine, where the system manager can look at it later and then decide whether it's okay and allowed on the network or whether it is malicious and should be deleted. Okay, user access levels. Think here about banks. You've got people within banks who've got different levels of authority, for example, to give loans. So you might have a lot of people who can authorize, and of course it's done electronically anyway, using credit scores now. But so giving £1,000 loan would be given with a relatively low threshold. But thinking about at higher levels, someone is going to authorize a £500 million loan. Well, that's going to only a certain number of people who can actually okay that kind of a deal, and it would go through many hands. But user access levels means that you're going to give administrative rights where you can get your hands on all of the data and all of the systems and all of the application. You're going to give that to a limited number of people. So at school, for example, the network manager and one other can go into any system there. So it's on a need to use basis, if that makes sense. And then you've got this idea of different types of access rights. So read only, where you can, so for example, the shared area on the school network, you can access files from there and save it into your area, but you can't write over them and you can't put stuff on that area. Then you've got create, where you can create new data. You've got write, where you can make changes to a file. And you've got delete, whether a user can delete data. So that's the idea of user access levels. And you can give people access to only certain data or only certain parts of the system, depending upon their role. Aditya is asking, are user access levels also on secondary storage devices? Yes, absolutely. You can set passwords, you can set access levels on all sorts of devices. And in fact, you can do it on a Mac or a PC. So you know when you add a new user, you can then dictate what levels of rights they have. Do they have access to... So, I mean, if you think about the sort of child protection measures, you can set up a children's account where they've got access to certain programs and not others, and where they've got access to certain websites and not others. We've got blacklisting and whitelisting, okay, where you can make certain sites available or block all sites apart from a certain number of sites. So yeah, good question. User access levels. So make sure you're happy with what all of these mean, and then the scenario in which you're going to use it. And this might become more obvious when I show you the big sheet at the end. I fear it's too much to put on one page, but we shall see. Passwords. So you've got all of these tools that you can use, but don't forget, when you look at the question, take your time and think, okay, which of these prevention tools is going to be appropriate for the job in hand? And that's what you need to focus on. If, like all of these different areas, there's a relatively small number of threats and therefore a relatively small number of preventative measures that you can use. So if you know them all and you understand why you would use one rather than the other, if this comes up in the exam, you can absolutely nail it. Okay, passwords. That's to make sure people don't get unauthorized access. And do you remember how, I think it was in the mock exam, there was a question about a car dealership? Is that ringing bells? And there was 2 marks for it. And you had to say that you would use a password for 1 mark, but to get the 2nd mark, you had to say that it prevented unauthorized access. So be a bit savvy with looking at these, at the questions and thinking how many marks are there for each one. If it's 2 marks, you've got to say 2 things. If there's 3 marks, it'll be an explanation plus 2 more things. And don't forget, it doesn't mean there are 2 different sentences. It means that you're saying 2 distinctly different things. Don't just start writing volume and think that will help, because that's not going to be the thing. Are you saying 2 distinctly different things? Don't repeat the point you've made. You won't get marks for it. All right. Changing passwords regularly. I'm going to come on. Sadly, Aditya, this is the case for most of us, which is why we get hacked and then we act really surprised when it happens. But the problem is, unless you use a password manager, which I keep intending to buy and actually do, unless you use one of those, you're quite vulnerable. I'm in the same position and I teach computer science. It's shocking, isn't it? So these are ideas for changing your password regularly. So they might ask you what steps you could take in terms of passwords, and it's going to be not using regular dictionary words, using numbers, lowercase, uppercase, and so on. And you know this because when you get anything on the internet and they always make you join up. If you buy something, you've got to sign up to their newsletter and get spammed every day with nonsense. And when it makes you choose a password, it's got to be ridiculously long, have a combination of uppercase, lowercase, special characters, etc. And then you forget it the second that you actually press enter. We've got encryption. Now, don't forget, encryption is turning plain text into ciphertext. There's 1 mark in the exam for that, turning plain text into ciphertext. Go to bbc.co.uk and Google encryption. There's a fabulous video. It only lasts about 2 minutes, and it talks about public keys and private keys. A bit more information. That's more at grade 9 there. So encryption is where data is scrambled before being sent across a network. And here's the key thing, is that if it's intercepted by a third party, it's unreadable. They can't do anything with it. So that's why you encrypt things. And the opposite of encrypt is to decrypt. That's when you unscramble it. And that will be an algorithm, a long set of numbers and letters that's been used to scramble the data, basically. And the Caesar cipher, it's a simple example, as in if you took the letter A and your cipher could be that A becomes B and B becomes C. So when you write it, it doesn't make much sense, but everyone knows the Caesar cipher, which is pretty rubbish, but it's a basic one. So that's an example of a cipher. All right, so listen, logical versus physical. Logical is all the stuff we talked about that involves software, but then you've got physical hardware. Sorry, it involves software or hardware, actually, because not forgetting that a firewall could be a physical box or it could be software, right? So physical security. So when they give a larger mark question, like 6 marks or 4 marks, and you're struggling around to think, well, I've talked about passwords, or I've talked about antivirus software, or I've talked about anti-malware, what else can I say? There's also physical security. For example, locking the computers inside a room. Then you've got restricting. Okay, you've got the idea of banning USB ports. So not allowing USB ports to be used so that people can't introduce viruses to the network or malware to the network using the USB, and equally can't steal data. We're not allowed to use USBs at school anymore. They've switched the USB ports off. Installing CCTV, actually one I hadn't thought of. Locking the server room. And there's also this idea of the locks on the laptops themselves. Those little cable locks you can get, which the sort of thing you'd use on your bicycle. So you can lock those to desks. And in offices where hot desking is a thing, where you don't have your own desk per se, but you sit down at wherever's free, and you want to go away to the loo or to get a coffee, you'd use that cable lock to lock your computer to it. So other physical security that's not on there, you've got biometrics, where it scans your iris or your fingerprint like you've got for your school lunches. That's another example, okay? So you've got biometric access as well. So that's physical security. So logical, computers and software. Physical, doors, security guard, CCTV, cable locks. So have that sort of collection of ideas that you can throw in depending upon the scenario, okay? So that's the physical security. I wonder if you can read this. I hope so, because there's a lot of information on here, but this is the do-all, be-all sort of... It's got everything on there. Now, I will send you a copy of this so that you can have a play with it. But working from up at the... Let's start on the top right, okay? And you've got your threats, and you need to make sure that you've got a way of solving each of these different threats. And I will send you. So this is an example of all of the different threat types that we have, but also in tandem with this, you've got all of the different mitigations. Okay, and that's what you need to think about. So I will send you this copy through, and I will also send you the list of what you can do to answer it. But very quickly, this one up here on the right hand side, I'm saying this up here, you can't see what I'm pointing at. On the right hand side, you see the malware where you've got worms, viruses, trojans, adware, ransomware. Don't forget, trojans are a method of deploying of malware rather than being malware in itself. All of this stuff on the right hand side, you just need to say anti-malware or antivirus software. So for viruses, antivirus software. For worms and for adware and for ransomware, anti-malware. For viruses, you could also say about using a firewall to prevent it, and that it's hardware or software. All right, so that deals with the right-hand side there. Now, can you see brute force attacks at the bottom? And this is where they use it's basically based on a dictionary. So they use a piece of software that's got all the dictionary words in it, all the numbers, all the letters, and they use combinations of everyday dictionary words to try to break into someone's account. And one way that you can mitigate against that is by using really complicated passwords, and don't forget numbers, letters, special characters, etc., because that makes it harder to guess. But another way that you can mitigate against brute force attacks is to limit the number of attempts. So, for example, you attempt to log in and it says you have 3 chances to log in, and after the third chance, you try for the 4th time, it locks the account. Okay, and with banks they do that all the time. You literally do get 3 chances, and if you don't, you've then got to ring a call center and spend ages trying to remember things that you can't remember. So that's something well worth remembering. Top left, data interception. So this is the man in the middle attack, and this is where you've got the person in point A over here, which you can just about see, the person in point B here, and somebody where my nose is in point C tries to steal the data while it's in transit, usually across a network. And hackers they get hold of special software called packet sniffing software, and they try to intercept the data. Now, you can't prevent that, but you can mitigate the data being of any use by encrypting it. So if you get any questions about data interception or data theft or man in the middle attack as it's known, you need to then mention encryption. And encryption, if they ask you more, encryption turning plain text into ciphertext, so that if the data is stolen, it's rendered unintelligible. It's useless because it's all encrypted and they can't read it. Okay, we've got DDoS attacks underneath that. Penetration testing. Remember, we talked about penetration testing can simulate large volumes of data on a website, on a what's the word I'm looking for? On a database. Okay, on a web server. Okay, what else have we got? The SQL injection. The SQL injection, and that is going to be data validation and input validation. Can you see input validation is when the passwords and the usernames that you enter. Do you remember that the SQL injection is when you're logging into a database, you put in the username, but then at the end of the password field, you add in some SQL code, and you're attempting to gain access at a higher level. We talked about access levels, to gain access to the database at a higher level to give you access to more accounts and more information. And the way you can do that is when you build the database, and this is about programming, isn't it? About robust programming, to make sure that the input, what is input in the password field and the username field for that matter, is actually checked to make sure that it isn't SQL code. So input validation, that's quite a nasty one. And they've not done that for a while. So if I was to guess, I think that might pitch up. Okay, I've got one more to do, which is social engineering. Social engineering is this idea of people as the weak point. And we've got 2 examples there. Phishing with a PH, which are those emails or web pages that pretend to be trustworthy, but they're not. And they try to trick people into giving out useful information. So, for example, getting one from the bank saying someone has tried to the order you place for £342 will be going through. If you didn't place this order, click here, and you think, oh no, I must click here and stop it. And then of course you put in your username and password, and they gain access because it's a spoof web page. It's not the web page you want. It's not a real bank web page. So you've got this idea of phishing, and the best way to prevent that is staff training. So you train your staff regularly about the phishing scams that are most likely to be out there and to recognize them. And the other one is shoulder surfing. And that again, you just train shoulder surfing, someone looking over your shoulder, watching you enter using the password, and then using it to get into the system. All right. So that is that's all of it. I have gone through that at 1,000,000 miles an hour, but what you can see on the page there is pretty much exactly what you're going to need. Okay, so that gives you everything that you require there. I will send you both the sheets. I've got one with just the threats and one with just the resolutions, but pretty much everything's on that page. In fact, this entire unit you are looking at on the page. Do you know what how all these different threats work? And do you know how they can be mitigated against? I'll try that again. Mitigated against. They make it tricky because the scenario that they choose will be applicable for only a certain number of threats or a certain number of mitigations, ways of preventing it. And by the way, you've got preventing, which is stopping it happening. You've got mitigating it, which is limiting the damage. It's like an SQL injection. Sorry, it's like a DDoS attack. You can't stop someone mounting one, but you can prevent significant damage being caused by it. All right. So that's the whole thing done on one page, and I'll put that on Satchel 1 for you tomorrow. Okay, we have reached the excitement of quiz time, so let's get on with that now. These should be relatively straightforward, I hope. So here we go. Which of the following are physical protection from threats? For once, I'm going to reset my timer and do it. There we go. So which of the following are physical protection from threats? Is it firewall, locks, encryption, or CCTV? I'm going to have a slurp of Coke. Oh, crumbs. The answers came in so quickly. I didn't have time for a slurp of Coke. We've got D from Aditya. Hi, Bogdan. We've got D and B. Emad is B. We've got Henry. Hi, Henry. Hope you're doing okay. We have got Hash Brown with B. We've got Flynn with B. We've got Aditi with B. We've got Henry again with B and D. Okay, so shall we see? Drum roll, please. Have I got a drum roll? I've got a glockenspiel. Not very close, but let's use that instead. So the answer is it was A and it was C. Now, that was quite sneaky. And in fact, this is incorrect, isn't it? This is incorrect because actually, physical protection could be a firewall because it can be hardware or software, but it's also locks and it's also CCTV. So actually the right answer is A, B and D. Can't get the staff, can you? So that's that's what you're looking at there. But listen, this notion of physical versus logical, okay? Actually, I'm going to take that back and I'm going to say, in fact, the answers should have been B and D. Because even though firewall is a physical device, it is still giving logical protection. Okay, good. So it is B and D, which I think Henry got it right, Aditi got it right, Flynn got it right. Yeah, you all got it right. Okay, only I got it wrong. Well, I'm glad you know what you're doing. That's very reassuring. B and D, physical versus logical. Happy with that? Okay, you wouldn't know this because I haven't told you, but let's... Oh, I just gave you the answer. That's poor skills. Should we go back and see what the question was? Encryption, which uses different keys to encrypt and decrypt, is known as what encryption? Not actually in the specification, if truth be told. This is more A-level. But you've got symmetric and asymmetric. And the fact that it's different keys is why it's asymmetric. So let's just move on. All I've got to do is press the button once, but I clearly didn't manage that there. No hands. Question 3. Select the rule which might form part of a strong password policy. I've remembered to set the timer again. Every 30 questions I do this just to build tension. I might press, there's an air horn. Yeah. Okay, oh, crumbs, you're at it already. So hang on. Bogdan said A and B. Yes. Aditya said B. Hash Brown said A and B. Oh, I'll put your answers up. Here we go. Henry, B and D. Bogdan, A and B. Aditya said B. Hash Brown said A, B. Henry said A, B, C. Emad said A and B. Right, drum roll, please. Have I not got a drum here? No. No, I haven't. I've got a bicycle horn. It's not really like a drum, is it? Oh, I know what I've got. Hang on. I've got that sort of lame Rocky Horror one. Not Rocky Horror, Rocky the boxing thing. There we go. Building suspense as we speak. Dun, dun, dun. My head. Well, okay. Again, it should be A, B, and C. I mean, A, B, and C are... A, B, and C would be right, but C would drive you absolutely mad, wouldn't it? I mean, changing it every 3 days. They make us change it at school every term, which is quite annoying. But every 3 days would be mad. So A and B probably better. But Henry, I will give you the benefit of the doubt. BOD for C, because that would work. It would make you very cross, but it would work if you. Although there are some passwords that make me set such a long. There are some sites that make me set such a long password that I may as well have to reset it every time that I use it. All right, this one. In a school, user access levels are used to A and B. B. Oh, hang on. Let me click here. We've got Emad, A and B. We have got Aditya, who is B. We've got Bogdan, which is B. You could defend this and say it depends how incompetent the teachers are. You've got Henry, who's B. You've got Hash Brown, who's got no faith in teachers at all. You're about right, I reckon. And A and B. Oh, I see. A and. Okay, you kept me hanging there, Hash Brown. So let's see. Drum roll, please. What we end up with. Yeah. I would say user access levels do stop teachers from deleting software. So while the answer might be B, I would have accepted A too. But don't tell anyone. Yusuf, hi Yusuf, how are you? You say B. You are spot on. What have I got? 3 minutes left. Okay, we're almost there, I think. I've got a couple more of these. What's next on the agenda? Oh, this is a bit unsafe because it's given us the answer straight away. So let's go through it anyway. Which of the following is because I can't press the button once. I get impatient because there's a lag. What is the computer science word for lag? Can someone put it in the comments? Lag. You see, I can't help but quiz you. Which of the following are features of a firewall filtering packets from known unsafe IP addresses? What is lag in computer? Ooh, look at Bogdan. Bogdan's good. That was fast. Bogdan, you deserve a special sound. Ooh, let's go for applause. Aditya, it's good, but Bogdan is the superstar. It is latency. Well done, Hash Brown. So that's what it's called. And that's when you're getting shot in these multiplayer games because your equipment isn't quite as fast. That's the latency that you're experiencing. Okay, where are we? Let's have a look. 18. Not many to go. Here we go. This one works. Select the appropriate method of preventing phishing. Oh, I'll set the timer. How exciting. I keep forgetting. There we go. But you get your blinking answers in. I've got the timer going. You get your answers in before I actually manage to click on. I was hoping to have at least one more slurp of my Coke. Oh, you're all so good. Aditya and Hash Brown and Emad and Bogdan. So Bogdan, I think that's quite an intelligent answer. However, if you want to prevent phishing, the best way of doing it, oh, my head's in the way. The way you do it is you train staff. Easy to remember, okay? Hopefully you are feeling fairly confident with this. Oh, this one again. We've got to go. There's 1 minute left. So I'm giving you the answers here. It's the last one. Question 7. Select all the appropriate methods of preventing unauthorized access to a computer. Those are the 3 you can pick. Guys, it's been a pleasure. 23 of you, some lurking. Those of you who are lurking, thanks for coming. Those of you who've got involved, thanks again, guys. Well done. I will send you this stuff through tomorrow. I will put this PDF on the website so you can access it. Yusuf, you are a superstar. We'll give you the benefit of the doubt. I'm sure that you hadn't seen the answers before doing A, B, and C, maybe. So listen, next week we will crack on with the next topic. I've got to say, I can't actually remember what it is, but it's the next thing in the syllabus. So I've got an alert going out to you with the link this time next week. So guys, I will see you then. It's 18:59. Let's see if I can close this down before it strikes 7 o'clock. Guys, have a lovely evening. See you tomorrow. Take care, guys. Bye-bye.